We're going to be doing a quick example of when we can factor trinomials where the a value is not 1, so we have a coefficient on the x squared term, and we're going to look at this in depth using the inspection method. So we have a polynomial here, 3x squared minus 4x minus 4. The first thing we notice is we have this a value of 3 out front. Let's even go ahead and label our parts here. Our a value is 3, right, the coefficient on the x squared term. Our b value is negative 4, the coefficient on the x term, including any signs. And our c value is also negative 4. The idea behind inspection factoring is to use the idea of understanding distribution. So something that looks like a plus b times c plus d. And using the idea, knowing that those first two terms, so a times c, we sometimes call this f if we're using that FOIL acronym. A times c, in this case, has to equal 3x squared. Right, so f, I'm going to call it, is going to be 3x squared. That's the product of the first term of the first binomial bracket times the first term of the second binomial bracket. We also know, based on multiplying constants, right, b times d, that's an L of our FOIL acronym, or the last term times the last term. That is going to have to be that negative 4. So L, our two constants, have to multiply to negative 4. So that can help us get started on our brackets. That can help us decide on the numbers that are going in all 4 of those spots. So with inspection, I'm going to jump straight to my final factored form. I'm going to put my brackets because I know that a trinomial will factor down into 2 binomial linear factors. And I'm going to ask myself, for this f, right, if I need to have the product be 3x squared, there's actually only one way for me to do that. And that's a 3x times an x, because we need both of these factors to have an x. So I can go ahead and I can replace one of my first terms with 3x and the other one with x. The L is going to get a little trickier. So we have here that our L, our last times last. So first, when we're talking about the f, we're talking about the product of these two highlighted in yellow. The last, we're talking about the product of these two terms that I've highlighted in blue that we haven't figured out yet. And we want to make sure that the product of those two blue highlighted spots is negative 4. We have a couple of ways to do that. Right? If I'm thinking about getting a product of negative 4, I can do negative 2 times positive 2. I can do negative 4 times positive 1. Or I could do positive 4 times negative 1. Right? I could also do positive 2 times negative 2, but that doesn't change from our first option. So we need to figure out which pair of numbers is going to go in here. And so that comes down to the other two steps of our FOIL acronym. We want to make sure the outsides, that's the insides, and the outsides, those two products, so b times c, right, or as we see, whatever we put in this first blue spot times x, combined with, right, a sum of whatever we put in this second blue box, multiplied by 3x, we need to make sure that the inside product and the outside product totals to that negative 4x, right? That b value that we had from the start. So the best way to go about this is to just do a bit of a guess and check, right? We could try right off the bat, we know we need a negative 4. That can kind of give you a hint of where you should be putting these numbers, right? We need a pretty big negative number, which means that I'm leaning towards choosing the negative 4 over the positive 4. Oops, I lost a negative sign here. Right, because I'm looking to get a total of negative 4. That means that the bigger of my two factors should be the negative one if I'm looking for a negative total sum. So let's try it. All right, this is the thing with inspection, is it's going to be a bit of guess and check. if I decide to put the -4 here, right, because I know that would be multiplied by that 3x outside times outside, I'm going to get a -12x. And then if on the inside I then have a +1 times an x, I'm going to get just an x. Our goal is for the sum of these two things to be -4. In this case, unfortunately, the sum of x and -12x is not -4x, it's actually -11. So that tells us that these options don't work. And the same thing is going to happen if we were to flip things around. We would get a 4 times x on the inside, and we would get a 3x times 1 on the outside. Either way, that's never going to sum to -4 for us. So we move on, we try our next option. Lucky for us, we know that they're both 2's. The only question now is, where am I going to put the signs? Which one of these is negative and which one is positive? And again, that comes down to the idea that I need to make sure that I'm getting a final total of that inside product, right, 2 times x, and the outside product, 3x times 2x, to be an overall -4. That's my hint that, again, the larger of these two products, so the 3x times -2, is going to give us -6. The x times +2, right, making sure that these terms are opposite signs because I know they have to also have a product of -4 from that c value. I can go ahead and decide my signs. The biggest recommendation I would make with inspection is to check your work at the end. Let's just drag this out of the way. Let's expand this back out. Let's make sure it works. So if I'm starting with 3x plus 2 and x minus 2, I'm going to make sure that as I distribute, right, multiply 3x times x and 3x times -2 and 2 times x and 2 times -2, that I want to make sure I get back to where I started. I want to make sure this gives me a 3x squared. This is going to be, oops, not a plus, sorry, a -6x plus 2x minus 4, which simplifies down to 3x squared minus 4x minus 4. So let's look at another example of this. So let's look at another example, and another way we could possibly set this up to help organize ourselves. So again, we're taking that idea that I need to find two numbers that multiply to 2x squared for my first times first, my f. And in this case, because 2 is a prime number, inspection is great for working with prime numbers. I know that it can be 2x times x. And then for my last times last, this time I'm trying to figure out what two numbers are going to multiply to +12. And while the signs aren't a big issue this time, I need to think of all the multiples of 12. So I could do, and let's start with one, let's try 6 and 2. So we have our first times first product, we have our last times last product, and the way that these are going to be combined when we multiply with the outside and the inside, 6 times x, these are going to be my inside multiples. 2x times 2, these are going to be my outside multiples. So we can start to think of those products to help us out. So I get a 6x from my 6 times x. I get a 4x from my 2x times 2. And I ask myself, what's the sum of that? 6x plus 4x. Our goal is 11. Unfortunately, this only gets us to 10x. So that's how we know that 6 and 2 aren't going to work. So let's try it again. Let's set it up again. I have 2x times x. And let's think of some other products to give us the 12 at the end. right? 12 can also be made up of 4 times 3. So let's try that. Let's do a 4 and a 3. Right, and again, we're seeing that across, we're getting that first and last. And then the diagonals, 4 times x is where we're going to get that outside. 2x times 3 is where we're going to get that outside. Sorry, that first one is inside. I'm going to get a 6x. Again, this time we end up with a 10x. So it's not working out for us, but remember, we can always switch up the order that we write these in, right? Because 4 times 3 and 3 times 4 are both going to work for us. So let's do 2x times x. Let's try 2 and 6, but pair them up differently. So now I'm doing 2 times x, and I get a 2x. I'm doing a 2x times 6, I get a 12x. That one's still not going to work out for us. But when we get to our last option, 2x times x, and I'm going to put the 3 first and the 4 after, we're now going to see that that inside product is 8x. That outside product is 3x. And those do have a sum of 11x. So one way you can consider setting up your inspection if you want to show a bit more work, this is going to tell us that I'm going to pair now vertically, right? I'm going to have my final result be 2x plus 3, and my second factor be x plus 4. That's how we're making sure we're doing that cross multiplication, right? I'm multiplying that 3 by the x between brackets, not straight across. I'm multiplying that 2x by the 4, again between brackets. And so this can be a handy way of organizing your work, especially when you're dealing with those composite numbers and there's multiple possibilities for your factors. So keep giving inspection a try. If you have any questions, let me know down below.